Controlling my Sonos system really sucks, so we're gonna try and fix it with one of these. Okay, so for those of you that don't know what Sonos is, it's a wireless home audio system. You can buy things like amps, speakers, sound bars, any kind of like audio equipment that Sony offers in this ecosystem. And what it does is it allows all these devices to connect over the network. Let's say you're watching a game on a TV in a living room, but you also want to play that audio throughout the house. And then let's say in another room, you have some in-ceiling speakers. So what you can do is you can buy something like this amp that powers the speakers that are in the ceiling, and then have a device like a sound bar hooked up to the TV in the living room. And if they're both part of the Sonos ecosystem, they then can connect together and sync up the audio and play in both spaces, so you have full home audio of one source. Or another scenario, which is the scenario that I'm in, is where I use these amps to power multiple rooms in the house that have speakers built into the ceilings, including spaces outside. What I can do is I can play music through one of the amps and then sync up all the other amps that are hooked up to the other rooms to that single amp and play the same music, and it's all synced perfect. It sounds perfect. There's no delay, things like that. So while in theory the Sonos ecosystem seems great, in practice it actually is really annoying to use. What I mean by that is, if you want to make any kind of adjustment to volume, or you want to connect other rooms together, you basically have to use their app. Now, there are other apps or other devices to control it, but everything is pretty complicated or expensive. All I'm looking for is some kind of basic hardware that just potentially communicates directly to this. Just a small dial, set of dials that represent all the rooms in the house, where I can just go over and adjust the volume from that dial no matter what. I don't have to go through menus. I don't have to select anything. All I have to do is reach for the dial for the specific room and turn it up or down. And when I started looking online, it didn't look like anything like that existed. Actually, let me read. I'm gonna read what this one guy said real quick. Hold on, because he summed it up pretty well. Okay, so I found this. It was on a Sonos user thread, and he was looking for best user-friendly Sonos controller. It was Go Team Tom. By the way, Go Team Tom, if you happen to be watching this video, continue watching, because I think I may be able to solve this problem. I have a Sonos system covering my entire house, and we often host and have visitors. I'm getting fed up with handing over my phone or asking people to download the app to control the music playing. Some of the speakers are out of reach, so a simple task of changing the volume is effort. Therefore, I want a wall-mounted device that can control my Sonos system. Ideally, a fairly user-friendly one, as I don't want people to have to struggle to use it. Does this such thing exist? Well, I can tell you, it basically does not, which is crazy. So the more I looked into this, it turns out that it seems like Sony just basically wants you to use their app, and that's it. And for how expensive these things can be, I find that wild to be the reality. Now, again, there are some universal remotes that you can use out there to set up scenes, things like that. But when you have someone over that doesn't know how to use devices in your house, or how everything's interconnected, using things like that, and when they don't work or when they reboot, it gets really complicated for someone just to do a simple task like turning down the volume in the kitchen or in the living room or in the bar or by the pool. I wanted to just set out and see if I can find a way to control this in a much better and user-friendly way. Something that everyone knows how to use, something that's more user-friendly. So then I just started wondering if there was some kind of API documentation for these where you can communicate to these directly. And it turns out there is. Sony has all of it documented online. And so you can make API calls directly to this through the local system. You don't have to use any kind of cloud, anything like that. And so with that, I was like, well, okay, if we can do that, then why don't we just use an ESP32 to communicate directly to this? So I wrote up a small program based off of the API documentation and just sent a simple command. I was able to simply turn the volume up and down on this using just this ESP32. And then I started thinking, okay, well, if we can do that, then why don't we just get a bunch of encoders? So that's where I am now. And the next steps are to develop a PCB. Let's throw an ESP32 on there, throw some encoders, some LEDs for some kind of indication or feedback, maybe an OLED screen. And we can start programming it, and maybe we can come up with some kind of remote to control these instead of having to deal with the crappy app on our phone. So let's see what we can do. All right, so let's start with what my plan is here. I plan to have a dial for each of my rooms, the rooms being bedroom, living room, kitchen, patio, and bar. And I want the controller to look something like this. Now, knowing how many rooms we have, we're going to need an encoder for each of those rooms. In the center, I'm going to put an OLED screen that we can use to display the volume for whatever room we start changing the volume on, or any other kind of information that we plan to use in the future. The sixth encoder in the top left is going to be the master volume to control all volumes at once. And the dial in the top right is going to be the dial for the room that the device is currently sitting in. So for example, I plan to have one of these panels in each of the rooms that has a Sonos device. So let's say this one that we're currently looking at would be the one to sit in the bar. If this one was sitting in the living room, then the dial in the top right would be the living room dial. This is going to be really important later whenever we're explaining how the grouping process works. Okay, next, let's talk about how the Sonos API actually works. So when you look at the documentation online, it looks like each Sonos device has a set of properties that you can call through the API. For me, the most important properties are going to be volume, ID, and coordinator. We'll get to the coordinator here in a minute. So let's go ahead and say we have a second Sonos box that has the same set of properties, with the top box being the bar and the bottom one being the kitchen. What happens when you go to group one speaker to another, whichever one you are grouping it to becomes the coordinator. So in this instance, if we were to group the kitchen to the bar becomes the coordinator of the group, so therefore the coordinator property of the kitchen says bar. So that is how we know when the kitchen is tied to the bar. In this scenario, whatever is playing on the bar speaker will be reflected on the kitchen speaker as well. So it's going to copy everything that the bar speaker is doing because the bar speaker is the coordinator. Now let's go ahead and take these two, we're going to shrink them down. So let's say we're adding two more speakers to our ecosystem, the living room and the bedroom. And then let's say that in bar we're playing song A, and then in the bedroom we're playing song B. And then at some point you send a group command to the bedroom to group to the bar. So you want the bedroom's coordinator to become the bar. What happens is the bedroom would then drop song B and start playing song A that is being played in the bar. Now, if you send another group command to the bedroom to group with the living room instead, and the living room is playing song C, the bedroom would then drop song A that's being played in the bar and then go to playing song C that's in the living room. With that, it would update its coordinator property and you would be able to see that it's grouped currently with the living room. So that's just kind of an overview of how the ecosystem and the API works. So let's go ahead and move on to what my plan is and how I think this will work with the ESP32. So we have a Sonos API, a local API, and we are communicating to that API over the Wi-Fi. The ESP32 has built-in Wi-Fi, so that's why we're going with the ESP32. With the ESP32, we need to think about the I/O that we have available and what we're going to need. So we know we're going to need 6 encoders, each encoder needing 2 I/O for the rotation and 1 I/O for the press. So that would end up being 3 I/O per encoder times the 6 encoders that we're going to need. So that means we're going to need 18 I/O total. And then the last thing that we're going to need is 1 I2C line for the OLED to be able to control that screen and be able to show the volume or any other information that we need. With that, we know that we have already exhausted all the I/O on the ESP32. There's no way that we're going to be able to control this many things and not run into problems. So we're going to need some kind of I/O expansion. I've used the MCP 23017 in the past. It's super easy to work with. It also uses I2C communication. So this would be really easy to integrate into the ESP32. What this does is it gives you 16 more I/O pins. They can be used for input and output. It also has built-in hardware interrupts that you can then send to the ESP32 for when the encoders are turning. So if we were to wire the ESP32 up to everything, it would look something like this. We have our I2C port going to the OLED. We also have the I2C port going to the I/O expansion, which then would take up the 12 encoder I/O for just the rotation, and then we'll use the remaining 4 I/O on the expansion for the LEDs for those 4 encoders on the bottom. The remaining I/O that we're going to need is 1 more LED for the top encoder, then 6 I/O for button presses. So that means we just need 7 more I/O that we could potentially claim on this ESP32 in addition to the I/O expansion. The next thing that we got to think about is the I/O expansion is going to need to be able to send an interrupt back to the ESP32 to let it know whenever a rotation is happening. Encoders get a little crazy when you're trying to read them and you have a bunch of them, because what happens is if it's rotating fast enough and the microprocessor isn't refreshing or scanning for that change fast enough, it may miss a beat, and so therefore your encoder won't feel smooth or reliable. It'll kind of like skip notches or skip steps. So one way to fix this is to just use a hardware interrupt, and what that does is that just sends a signal to the ESP32 saying, hey, something has changed, you need to update your values. And so that is going to be something that's really important to have. One of the problems we're going to run into here, though, is the ESP32 does not reliably run I2C communication inside of hardware interrupt routines. This has something, I believe, something to do with the RAM or the way that the routines are ran on the memory. And so there are ways around this, but I didn't really want to dig deep into this and wanted to just find a quick and easier solution. This ended up making it a little more difficult in the end, I think, but what I ended up doing instead was, instead of just using the ESP32 as a standalone microprocessor for this whole thing, I ended up adding in one more processor, an Atmel 32U4, also known as the Leonardo on Arduino. What we can do is we can throw one of these on the PCB, we can throw the Arduino bootloader into it, and then we can program it using Arduino. Then we're going to tie the Atmel 32U4 to the ESP32 through UART serial, and we can then send data back and forth. Then using the Atmel 32U4 or the Leonardo, we can then tie in all of that I/O that we discussed with the ESP32, and this also helps out a lot because the Atmel 32U4 has a lot more spare I/O that we can use for our button presses, any other LEDs that we need, and plus, the most important part, there is an available hardware interrupt pin. The way that I envision the overall program working is the Atmel 32U4, since it runs so much slower, and then on top of that, the Wi-Fi request on the Sonos API may be kind of slow. The timing is going to be very important between these two devices. So I think what I'm going to do is have the Atmel 32U4 be the main program that decides everything, that updates everything, and all it does is it sends requests to the ESP32 to get updated statuses of all of the Sonos devices on the network, and then send that request data back to the 32U4 through serial. That way the 32U4 would almost be like the heartbeat of the system. It would be sending requests to the ESP32, then waiting for the response to come back before moving on to the next request. In the meantime, it will also be waiting for any kind of changes on the I/O, including the I/O expansion. And so it's kind of the guy in the middle that's going to be managing the data going to and from Sonos. So with all these ideas in mind, I'm going to go ahead and get started on developing a PCB. So this project went way smoother than I expected it to, other than running into a few issues with the programming. I made some mistakes on the PCB that I'll go over here in a second. But for the most part, we now have a working Sonos controller that controls all the amps in my house. It can adjust the volume. It can group and ungroup rooms very quickly without having to rely on an app or any other kind of software. So I'll go over a few of the things that I ran into while I was making this. But like I said, it was pretty easy and straightforward, and I didn't run into any major roadblocks. The first thing I ran into, though, was when I developed the PCB, I did not pay close attention. You probably noticed that the encoders were not soldered directly to the board like I had originally planned, and that's because I actually flipped these on accident whenever I put them on the PCB. So whenever I designed the PCB, I had actually flipped these headers around. So technically the direction of the dials would have been this way. But I wanted to keep everything as small as possible. So what I ended up doing was 3D printing a little bracket that just glued and mounted to this. And then I ran individual wires and then just crossed them and soldered them to the right header pin. So that was the first issue I ran into, and I'll fix that on the next version of the PCB. The next issue that I ran into was I went through all this trouble putting two processors on there because I didn't want to have to deal with the interrupt and I2C on the 32U4. But for some reason, whenever I was programming it, every time that I tried to use interrupts, I was running into issues. It was probably an issue with my programming, but trying to get this video out and trying to hurry, I kind of just gave up on that. So right now, the encoders are actually on a scan, which is not great. They're still pretty responsive. It's not as terrible as I expected it to be, especially for having 6 of them on there. But it still could be better, and I think in future versions of this, I also want to figure out a better way to handle that interrupt and figure out maybe if it was just something I was doing wrong in the programming. The next issue that I ran into or noticed after the fact was the placement of the LEDs. So I'm going to go ahead and just turn one of these on real quick. But the placement of the LED for this dial just doesn't seem right. They're on top. Going back, I'll probably end up putting the LEDs under the dials to make it clear which LED belongs to what dial. The top LED for this dial up here actually ended up being behind the OLED, so you can't even see it. But for the most part, this turned out better than I expected it to. The last thing that I think I will probably end up doing is just changing the screen, the graphic, and how it displays the volume, make it something a little nicer. This is what I just wanted to have for now, just to make sure everything's working. And other than that, I mean, everything else was fine. One other trick that you probably noticed was when I was laser cutting the acrylic out for the faceplate, the etching that the laser did for the room names, it just did not stand out well enough for me, and I wanted it to stand out more. So what I ended up doing was spray painting. So where this is etched, it's like slightly deeper than the surface of the acrylic. And so what I ended up doing was, for this one, was spray painting the whole front of this acrylic and then just taking a paper towel and wiping it away real quick, and then letting it dry. And that ended up making this look a lot better. And I was actually kind of proud of that and really happy that turned out that well. The other thing that you probably noticed, there were some really small JST headers on that PCB. It was because I was using them for temporary USB. The other JST header was for that OLED. The way that I'm powering this is the ESP32 is on the back. And so I have the USB exposed coming out the back and having it where you can plug in the USB into the back. And I'm using the 5 volts from the USB to power the whole thing, and then the 3 volts that's being created on the ESP32, I'm using that as the logic level shifter voltage. So basically I have my 3.3 and 5 volts inside of this going through the ESP32, which turned out really convenient. So let me go ahead and show you how this works. I'm going to end up screen recording this. So let me go ahead and start that. I was going to bring a speaker in here, but realized that was going to be a problem with music. So I'm not going to show this with music, but I will show you in the Sonos app what it looks like when you're controlling it from here. So let me go ahead and start this recording. Okay, so right now, you notice that it's already grouped with the bar in the kitchen. That was because when I clicked to this dial earlier, it grouped the kitchen to the bar, and that's why you see the LED. Remember, when we created this first one, this is for the bar. You can tell that this is for the bar because the room name is on the very top right dial. So what that means is anything that you try to group on this dial automatically knows that the bar is the coordinator. So what it's going to do is when you click one of these dials, so this next one I believe is going to be the living room. When you click this one here, it will automatically group the living room to the bar. And then if you want to ungroup it, all you have to do is just click it again and it will ungroup it. So this is what I mean by making this much easier. So normally if you want to group and ungroup these, you have to do this for the most part inside the Sonos app. So if you're playing music on Spotify, you can turn music up and down all you want, but you can't really group and ungroup. If you go to try to group inside Spotify, it takes you to the Sonos app. So for example, if someone comes over and they want to play something on Spotify, and it's normally easy for them, they can just play Spotify and then select the speaker in the room and it will start playing. But if they want to end up grouping them or anything like that, they would have to have the Sonos app and then they'd have to connect to all my speakers, things like that. So the main point of this was to solve that problem, to make it easier where anyone can just walk up and just easily group and ungroup rooms by just clicking a dial. And then if you need to turn volume up and down, so I'm going to go in here just to show this is the bar speaker. So if I go to just turn this dial up and down, this will just adjust the volume. And then again, if you just want to add another room, you just hold the dial and it'll add the patio. You want to ungroup the patio, you can ungroup the patio. If you have multiple, I mean, even just doing this, how quick this is crazy because it was so much slower before whenever you're trying to do it through the app. So if you have all of them grouped like this, if you want to quickly ungroup all of them, then you can just hold the bar and it will end up ungrouping all of them at once. So now you can individually group and ungroup very quickly using just this. So this was the main goal I set out for. I just wanted something that was easier to just adjust the volume and group and ungroup. Like I said in the beginning of the video, I understand that there are universal remotes out there that do this in a way. I believe in my research, I did find there's like some kind of panel that Sonos makes that you put in a room on the wall or something that kind of does this, but it doesn't look like they really support it anymore, or at least I can only find secondhand ones. So I don't really know what the story is behind that. But even then, it still has like a screen and a bunch of navigation and stuff like that from what I was seeing online and like demonstrations of it. I just wanted a dial and a button. And the other challenge for this is that the amps that I have are in a server closet. They're not in the room that the speakers are in. So that is another layer of you can't just have a remote to turn it up and down. Maybe if you had if they're like Wi-Fi or radio or something like that over radio. But this right here, communicating directly to the speaker, is just so much easier and just makes so much more sense to me. So anyways, I really enjoyed making this video. This project, I expected it to only take me about 2 weeks to actually finish. And I was hoping to post the video on schedule I was planning on trying to do a video every 2 weeks, but this one kind of proved that that is a challenge when you're making something from start to finish. But I did want to just try to make something start to finish and have a full complete project just to kind of show the things that I plan to show on this channel, not just the first couple videos, but anything that I'm working on, any kind of idea that I have. This is one that I've been sitting on for a long time, that every time that I run into this problem, I was like, man, I just really need to make something like this. I think I can do it. So making a video for it was the motivation for me to see it all the way through and work on it basically nonstop until I got to the end. So I really hope you enjoyed this video. Make sure you like and subscribe, and I will see you in the next one.